Hey guys, it's A&T Academy with a math tutorial on
integers and their absolute values.
So when we talk about integers, we mean whole numbers. So these could be positive or negative numbers. So if you've never really worked with integers, you might have only seen this side of the number line, so just the right side or the positive side. But there also is a negative sign to the number line. So again, the negative numbers are represented by the negative sign, and the positive numbers are represented by a plus. However, it is implied, so you don't need to put that. So again, negative numbers, left side, positive numbers, right side. Integers are just whole numbers. So 4.5 would not be an integer because that is a decimal. 2/3 would not be an integer because that is a fraction. So opposites is something else you might need to know. So -5 and 5 are opposites. -4 and 4 are opposites. -3 and 3 are opposites. So opposites are basically just a number and the same number just with a negative sign. So when you talk about absolute value, we might say absolute value is represented by two lines around a number. So the absolute value of -5 is just a distance from -5 to 0. So this would be from here to here. This is 1, 2, 3, 4, 5. That is 5 jumps. So the absolute value of -5 would be equal to 5. And the absolute value of 5 is also equal to 5, right? 1, 2, 3, 4, 5. So the absolute value of 5 is equal to 5. However, if you have, let's say, the absolute value of 2, and there's a negative sign outside of it, then this will be a negative number. So the absolute value of 2 is 2, and then this will be equal to -2. And so opposites will have the same absolute value because they're the same distance away from the number line. Here is my partner who's adding and subtracting integers.
So when you want to add and subtract integers, you want to know two basic rules. So the first rule is that so adding a negative is like to any number is basically like subtracting a positive. And subtracting a negative is basically like adding a positive to any number. So now those may seem confusing, but I'm going to show you two examples which actually follow the lines of these rules and would help you understand them more. So here's our first example. So I'm going to do positive 3 plus -4. So now usually it's orthodox to put parentheses around the -4 so people do not get confused by the plus and the minus sign. So now first we want to locate 3. So now 3 is, because we're going along the first rule, we have to make 4 jumps to the negative side, because like we said, adding a negative to any number is like minusing a positive. So it's basically 3 minus 4. So that's a simplified version. 3 minus 4. And now 3 minus 4 can be easily represented by using a number line. You can make 4 jumps to the negative side or the left side. So now 1, 2, 3, 4. So now those 4 jumps are basically every single part of the number. So 3 minus 4 in conclusion equals -1. So now here's another example. You might get confused by the jumps a little, so I'm gonna erase some of them. Both of them actually. So now here's another example. So 5 minus -6. So now this is the second rule, going along the lines of the second rule. So now subtracting a negative is basically like adding a positive. So we can simplify this into 5 plus 6. And also, if you want to think about it, you can also imagine those two negative signs, oopsie, in the problem one can be tilted to the opposite side, and it can make a plus sign. So that helped me when I was doing integers at first, but I don't know if it'll help you, but it's a good strategy. So now 5 plus 6. Many of you should know that the sum is 11. And here's my partner. So those were the two addition and subtraction rules and some examples to help you understand them. And now here's my partner in multiplication and division with integers.
So, multiplication and division with integers. So, when you talk about multiplication and division, when you're multiplying and dividing negative and positive numbers, you want to remember that if you have an odd number of negative numbers in your equation, the product or quotient will be a negative numbers. If you have an even number of negative numbers in your equation, the quotient or product will be a positive number. So, it might be confusing, but here's some examples to help you out. So let's say we have -5 times 7. So you see that dot I just wrote there? So that dot, let me make this bigger just so you can see. So again, that dot is to represent multiplication, because in algebra, if you use x as times, then you might be confused with the common variable x. So, -5 times 7, since you have an odd number of negatives, right, only one, which is an odd number, you want to disregard that for now. Now 5 times 7 is 35. So let's say you have 35. Now, since it's an odd number of negatives, you have one negative, this product will be a negative number, and so the answer is -35. Let's try another one. -5 times -7. So now you have 2, right? So these two negatives will cancel each other out. Like my partner said, you can put the first one and then tilt the other one to make a plus sign. So 5 times 7 is 35. And we disregarded the negatives. 2 negatives equal to positive. The product is positive 35. Now, we did put a plus sign. However, the plus sign for a positive is implied because there is no negative. So you don't need to put this when you're solving problems like these. Now let's try some division examples. Same numbers. So let's say you have -35 divided by +7. So now, you have one negative, so it's an odd number, so the quotient will be a negative number, and we can disregard that for now. 35 divided by 7 is 5. So we can put that up here, and since it's one negative, it'll be a negative number, and so the answer will be -5. Now let's say you have another example. -35 divided by -7. Okay? So you have two negatives, so the answer will be a positive number. 35 divided by 7 is 5. We can put that right up here. And then two negatives equal to positive. It'll be a +5. Now that's our answer. But remember again, the positive is implied, so you don't even need that. So the answer is 5. Now, here is my partner with comparing integers.
Yep. So comparing integers is very important. A little side note I would like to add. Sorry for the glare of the lights because it's in daytime. So, the 5 in one of his first division problems probably got a little cut out because of the glare. So we're sorry for that. So comparing integers. So now this is also very resourceful, especially if you want to order integers from least to greatest or greatest to least, that my partner will go over in after we go over comparing. So we're going to take two integers. So now we're going to take -3, all right, and we're going to take 2. So now most of you would know that -3 would be less than 2, because if you want to look at the number line, -3 is actually is to the negative side of 2 or to the left side of 2, which makes it less than. So that gives you the easy answer that 2 is actually greater than -3, regardless of the number. Regardless of the numbers, see, like 2 is less than 3, but 2 is greater than -3 because 2 is to the right of -3, and 3 is to the left of 2. So now, to help you be safe, from confusion, we're going to put two negative numbers in and ask you to compare them. Erase is getting a little jumpy. So we're going to take -3 and -5. So now -3 and -5 are both in the negative side. So you don't really know exactly which one is greater or less than if you don't know the proper method. So just cutting down the glare. So -3 and -5. -3 is to the right of -5, as seen on this number line, which means that -5 would obviously be less than -3. So I'm going to give you one final example. So it's going to be -7 and -9. Whoopsie, 9's kind of weird. So -7 and -9, and I would encourage all of you to pause the video now here and think about what would be greater than and what would be less than. So I'm going to give you a few seconds to think about this, and yeah, I'm going to wait for 3 seconds in the video itself, where you can just pause the video and give you unlimited time. So I'm going to wait for 3 seconds now. And now, yeah, those 3 seconds should have been easy, well, should have been helpful for you to calculate the correct answer. Well, this 9's kind of weird again. So the answer is that -9 is less than -7. And -7 is greater than -9. Because if we continue this number line for on and on, -7 would be to the right side of -9. So, which makes it greater than. So also, why we're doing this left and right thing is because it's actually correct, mathematically correct. Whoever does it, whoever thinks that the positive numbers belong on the left and negative on the right is wrong. Therefore, I'm referring to the actual term. So yeah. And now here is my partner on ordering integers, which is basically the same thing as comparing them, except now you're putting them from least to greatest or greatest to least, which in turn involves like comparing multiple integers. So, without further ado.
So, comparing or ordering integers. So when we're ordering integers, let's say we have a few numbers: -7, -5, 3, 4, and -2. So now we have 3 negatives, 2 positives. That doesn't really matter, but just saying. So we obviously know positive numbers are greater than negative numbers. So this will be on the rightmost side, these two, and this and these two will be on the left side, or greater to the left. So -7 is the least number here, because when you're comparing -7 and -5 and -2, it's kind of like the opposite of positive numbers, because you might think if it was positive, 7 is the greater number, because it goes 1, 2, 3, 4, 5, 6, 7. 7 is the greatest. However, on a negative, it's sort of the opposite. So -7 will be least. Now, going by that rule is how it's the opposite. -5 will be next, because -5 is less than -2. And then -2 will be next, because it's the only negative number left. And 3 and 4 are positive, so they will be obviously greater, because negative numbers are always less than positive numbers. So -2. Now, we have 3 and 4. So now, since we probably already know how to work with positive numbers, right? So 3 and 4 will be next. 3, 4. So this is your number line from least to greatest. -7 is the least to 4 is the greatest. -7, -5, -2, 3, and 4. So, that was our video, guys. So just to recap, we did addition, subtraction with integers, multiplication and division with integers. We did comparing and ordering with integers, and absolute value.
And don't forget that also like decimals also go along these methods. Integers are just like, are a little easier, a lot easier to find these stuff instead of decimals. We'll do a video on that soon.
The rational numbers, because they are rational numbers.
Yeah.
So again, that was our video. Make sure to check out our gaming and our science videos. We'll stay tuned for more math videos on solving inequalities, and maybe something with graphing and squaring and all that sort of fun stuff. Anything you gotta say?
Oh yeah, just make sure you look out for the squaring videos, because it's this is kind of like mathematician stuff. It's very important, and you can easily impress your teachers and friends by easily like a method to easily square 2-digit numbers and 3-digit numbers, which, believe it or not, are actually are a lot easier than just squaring 42. Like 42 times 42, it's like quite hard, right? So we're gonna post some videos on easier methods, and don't forget to check out our gaming and science videos.
Yep.
Yeah.
Bye, guys.